Let's say you are at the edge of some cliff and you drop a ball. What would a graph of its distance from you over time be? At first, the ball is going to speed up or accelerate as it falls, and then, due to terminal velocity, air resistance will cancel out the force of gravity until the ball just falls at a constant rate. So the graph will look something like this. This is a graph of the ball's speed, distance over time. But how exactly do we find the ball's speed at a given time? We have this curve, but where is the actual speed of the ball? The answer lies in the slope. To find the speed of the ball at a given point, we must find the slope of that point, because slope is rise over run. And in this graph, rise is distance and run is time, and distance over time is speed. Thus, slope is speed. But wait a minute. How do you find the slope of a point? Don't you need 2 points? No worries, we'll just make up a point. It'll make sense later. Let's call this whole function f of x. The point whose slope you're trying to find is at x, comma f of x. The point we are making up will be h away from x. Thus, the point we are making up is at x plus h, comma f of x plus h. Agreed? Good. Now, the slope between these 2 points, if we use the formula we all know and love, will be f of x minus f of x plus h over x minus x plus h. That'll simplify down to f of x plus h minus f of x over h. Now, as h gets smaller and smaller, the point we will make up will get closer and closer to our real point, making our slope more and more accurate. So why not plug in 0 to our amazing formula, you may ask? Well, if we do that, we end up with 0 over 0, which is an indeterminate form, meaning don't plug in 0. To express we want h to get smaller and smaller without reaching 0, we need to use limit notation. We need to slap this baby onto the equation, which reads the limit as h approaches 0 of f of x plus h minus f of x over h. And voila! That is how you find the slope of a point on a graph. Since you need to know what f of x is, and the formula for a speed of a falling ball is a little complicated, let's use something similar but less intimidating. The parabola y equals x squared. If you define f of x as x squared and you use the slope of a point formula we made, you end up having to cancel out some h's to get this as the slope of a given point on the graph of x squared. The whole business of finding slopes of graphs is known as derivation, or finding derivatives. The derivative of x squared is 2x. The derivative of x cubed is 3x squared. And if we go back to our example with the ball, the derivative of speed with respect to time is acceleration. If we graph the slopes of the speed graph we made as speed versus time, we get the acceleration graph that looks something like this. And, interesting fact, speed is actually the derivation of position with respect to time. So it goes position, speed, acceleration, and then this last thing which is called jerk, which is the derivative of acceleration. So next time you call someone a jerk, just remember you are calling them the derivative of acceleration. Anyways, that's all for now. NJ Bergam will be pumping out some more math videos, so come back soon to check them out. For now, like, subscribe, comment, and thanks for watching.